Greetings. Welcome to the Wired Edge Workshop. I have a new project I'm working on, and I thought I'd take a moment to kind of highlight the purpose of it, discuss from a pretty high overview of what the system is and what it's meant to do, and then just run through the components that I need to put this proof of concept together. The shortest answer for what this device is, this is meant to be a troubleshooting and diagnostic aid. There's going to be a connection for connecting what's called the device under test, and then there'll be some stuff going on inside, and then a interface to attach a display for the operator or user to interface. And then whatever's going on inside here is making that connection between user interface and the device under test. So some of the requirements for this is that it must be reasonably portable. Hopefully try and keep out as much dust and water as possible. I'm not intending for it to be necessarily waterproof, but I'd like to keep out dust. And third is that it must have its own, say, internal power supply, and then the ability, perhaps on the side here, to connect in a external power supply. High level overview, system-wise, I kind of gave it away at the beginning. We have a power supply with some interconnects going on here, and that'll allow an interface of the user interface, display, whatever it may be, to then communicate and get power for the device under test. That's basically its purpose. It doesn't do a lot of, let's say, intelligent stuff. It's an interconnection device, if you will. So some of the components that I need to make this work. First off, it has to provide the connection to the device under test. And this is running at basically automotive voltages. So 12 to 15 volts at the connector. Maximum of 50 amps, but that's not necessary in most cases. Most cases they'll be under 15 amps continuous. I have no interest in lugging around a 12 volt lead acid battery, and out of some smaller 12 volt batteries you may not get that current output that you're looking for. So that's where a portable tool battery comes into play. This happens to be a DeWalt, but that's because that's what I have for portable tools, cordless tools. Battery, I need some way to make a connection to the outside world. So we have a battery connection device here. You can get these on Amazon. Connects to the battery. Now I have my 18 volts available at my connector. I need to change that 18 volts and bring it down to 12 to 15. I'm trying to target 13 volts. This here is called a buck converter. It is a DC to DC step-down converter. There are many different names for it. This input voltage on this is up to 75 volts DC, so we're good there. It'll accept the 20 to 18 volts that this battery puts out. The output is regulated, so I can adjust the output voltage and bring it down to the 13 volts that I want to see, and I have already done that. And because I am somewhat good at destroying cheapo electronic devices, I've put a inline fuse. I think I've got it capped at 15 amps right now. Hopefully I don't destroy this by trying to get too much current from it. Oh, this is rated at 500 watts. Should be. That's what the internet ad says, or Amazon post says. 13 volts, 500 watts is roughly, it's give or take 40 amps, plus or minus, more plus, whatever. Battery's good for that. Not, well, continuous, it would handle that for a while. You'll eventually drain the battery over time. Considering I'm not looking for that as continuous, it'd be intermittent, 10 amps. This is going to last for quite a while at 10 amps. The component here that I need to get to complete this is, this does not have a low voltage disconnect. And my battery, I don't want to drain this battery past 16 volts on the disconnect, simply because I'm not putting a battery management or balancing system in this. The actual portable cordless tool, there may be some stuff that goes on between the tool and the battery to make sure that an individual cell in this battery does not drop below, I think, like a 2.7 volt threshold. My goal is just to cut it off at 16 volts, which should hopefully preserve any of the cells if one of them is weaker than the others and is starting to drain. So I need to source a battery disconnect, a low voltage disconnect that I can put in here. Oh, what else here? So we have our connector for the device under test. So I got to put a hole in the side of this. That's going to make this non-watertight anymore. I think I can leave the battery inside and close the lid up. There will be some heat that needs to dissipate, but if it's being used, actively used, the lid is more than likely probably going to be open, and this any hot air generated can be just come out right at the top. If I do, I can maybe put like a computer fan on the outside and rig it either some sort of temperature sensor or just have it turn on when this turns on. That does create a problem for water and dust tightness, but I think it'll be okay. Then there'll need to be some connectors on, probably on this side or somewhere on the other side, to connect a display or user interface. And then also I want to be able to bring in like battery voltage from an external source. But I think that about does it for a short overview and components that I need for proof of concept. There'll be some wiring and relays that take place in here. I also need to figure out how to mount all this stuff so that I'm not putting holes, like, you know, screwing to the side of the inside here and putting holes in the side. This case is a Harbor Freight knockoff of a Pelican case. Should be sufficient for my proof of concept. So I appreciate you taking the time to watch this. If you want to see more of me putting this together, please go ahead and subscribe to my channel. Feel free to hit the like button and, as always, share it with someone else that might be interested. Thanks for watching.